So we have revised about the concept of wave function from Schrodinger's equation as well as Heisenberg's uncertainty principle. Here psi, this letter psi is called wave function. So the position of electron can be represented either in the rectilinear coordinates or polar coordinates. If it is represented as rectilinear coordinates, it is merely called wave function. In that case, wave function is denoted as psi is a function of x, y, z. If the position of electron is represented as in terms of radius and angle from the origin or baseline, it is represented as radial wave function. Radial wave function is also a function, but the functions are not same. That is why two different letters. Psi is a function of x, y, z, whereas the same psi is a function of g of r theta. G of r and theta. Here psi can be negative value. In some, if you solve the equation, psi can take the negative value. But position, negative distance is meaningless. Negative distance is meaningless. So we take only the square value. So the physical significance of psi squared. Psi squared is called probability density function. Probability density function. So this function can be negative. Function can be negative, meaningless. So it is taken as square so that it acquires positive charge. So positive value. Psi squared physical significance is the probability density function. What is meant by probability density function? The probability of finding the electron at a particular place. For example, if you take the nucleus you cannot find the electron. Nucleus consists of only protons and electrons. So probability of finding the electron into the nucleus is 0. Probability of finding the electron is into the nucleus, or probability of finding the electron outside the space is also 0. So probability lies between certain areas because it is controlled by nuclear attraction and also inter-electronic repulsion. So the position of electron is controlled by nuclear attraction and inter-electronic repulsion. So repulsion is a negative force, attraction is a positive force which cancels one another. Accordingly, it can take positive or negative value. So psi squared is the probability density function that is to be noted. Since it is a quantum mechanical approach, position of electron is not same all the time. The position of electron is governed by four important quantum numbers: principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. So position of electron, for example, carbon contains 6 electrons. Each electron has to be identified. Yeah, if a person has to be identified, means that in terms of its residence street. So if everything goes together, fingerprints will change from person to person. Everything can be same, but fingerprints cannot be same. So that is called address. So when we arrange the student's name, if the two names are same, we arrange according to the date of birth. Initially we arrange in terms of alphabetical order. If they are same, arrange in terms of date of birth. So even then it goes, you expand father's name like that. Here also there are some distinguishing features. How to distinguish two electrons? At least two electrons. So carbon contains 6 electrons means each electron has to be properly identified. Identity is given by 4 quantum numbers. Principal quantum number, this we have studied, we are revising. Principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. Principal quantum number is denoted as n. It gives information about the shell in which the electrons are present. So the shells are means different orbits. First nucleus. So the shell first orbit from the nucleus is called K shell. Next orbit from the nucleus is L, like that. K, L, M, N, O. Shells are represented as capital letters K, L, M and O. So if the electron is present in K shell, its principal quantum number is 1. If the electron, like this, if the electrons are present in L shell or M shell or N shell or O shell, the respective principal quantum numbers are 1, 2, 3, 4, 5, etc. starting from K to N. So principal quantum number gives information about the shell in which the electron is present. So one shell can contain more than one electron. Next system is azimuthal quantum number. It is denoted as L, small l. So azimuthal quantum number gives information about the subshell. This shell is equivalent to orbit, whereas subshell is equivalent. It is not same. Orbital. So orbital is a three-dimensional version of orbit. Orbital is a three-dimensional. If you draw a circle like this, if you draw sphere, once again like this, but you got to write sphere. So the sphere is three-dimensional. Circle is two-dimensional. So the electron, the azimuthal quantum number gives information about the subshells in which the electrons are present. Important subshells are, subshell are also called orbital, s orbital, p orbital, d orbital and f orbital. G orbital they are proposed, but there is no element with the electrons in the g orbital. So orbital letters are denoted, subshells are denoted as small letters, shells names denoted as capital letters. So azimuthal quantum number gives information about the, what is meant by orbital? Subshell. Subshell, so this is the, s orbital is spherical in shape, p orbital is, it is called dumbbell shaped. So it is made up of two lobes. One lobe is called positive lobe, another lobe is called negative lobe. What is the significance? This is the nucleus. So they are collecting the positions of electrons where, because it is in motion, constant motion. So where at all it moves, they collect the all, it is moving in all direction, exact the x direction, y direction, z direction. Spherical in nature, dumbbell shape. This is the shape, four lobes are made up, constituted in the d orbital. F orbital structure is still more complicated. So azimuthal quantum number gives information about the subshells or orbitals in which the electron. Next, magnetic quantum number is denoted as m. Magnetic quantum number means that it is not, already you have seen about the splitting. Spectral lines are split in the presence of electric field or magnetic field. S orbital is not split in the presence of magnetic field. So only one type of s orbital, but there are three types of p orbital, there are 5 types of d orbital, there are 7 types of f orbital. This splitting is called degeneracy. Degeneracy means they orient in different directions. They orient in different directions. In Navagraha, each graha is oriented in different direction. So as to have minimal effect. So s orbital degeneracy is only one. It is not splitting. P orbital 3 types. So this splitting takes place only in the magnetic field. That is why it is called magnetic quantum number. Splitting takes place only in the magnetic field, that is denoted by small letter. So shell, subshell and then splitting of the subshell in the presence of magnetic field like that. So only one type of s orbital. 3 types of p orbital are denoted as px, py, pz. The same structure located along the x-axis, located along the y-axis, located along the z-axis. Accordingly, it is called px, py, pz. And there are 5 types of d orbital. How it is oriented? 5 different directions: xy plane, yz plane, xz plane, z square plane, like that. Max. So in any orbital, only 2 electrons is possible. In any orbital, only 2 electrons are possible, because electrons are negatively charged, both the electrons are negatively charged. When they come closer, they will repel each other. They cannot go beyond the nuclear attractive. They cannot come closer than the interelectronic repulsion. So one spin, both are stable in the spinning. One spins in the clockwise direction, another spins in the anti-clockwise direction. The spinning direction is given by spin quantum number. Spin quantum number is denoted as small s. So there are 2 values. S equal to plus of means clockwise spin, S equal to minus of means anti-clockwise spin. So this is the arrangement, electronic configuration. Whenever you tell an electron in which shell the electron is present, in which subshell the electron is present, in which subshell which is oriented in which direction it is present, in any orbital, whether it is spinning in the clockwise direction or it is spinning in the anti-clock. For any electron, this will not be same. Next is the electronic configuration. Electronic configuration is given by 3 important principles. One is called Aufbau principle, AUF, BU, BAU. Second one is Hund's rule. Third one is Pauli's exclusion principle. Aufbau principle states that electrons fill in the increasing order of energy level, lowest energy level, E0, E1, E2, like that. So, electrons are ground state, then excited state, like that. So, Aufbau principle states that electrons fill in the increasing order of energy level. Increasing order of energy level. Second rule is Hund's rule. Hund's rule solves the type. We have seen that there are three types of p orbitals. All the p orbitals have the same energy content. All the p orbitals have the same energy content. P orbital energy is higher than that of s orbital. So, when s orbital is filled, next electron goes to p orbital. But there are three types of p orbital. One along the x direction, another along the y direction, z direction, like that. So, when first electron comes to px, second electron tie arise, whether it can come to only px or it goes to py. Second electron will go to py. Third electron will go to pz. Only the fourth electron comes to the px orbital. Or in other words, electrons tend to remain unpaired. The essence of Hund's rule of multiplicity is that electrons tend to remain unpaired. Unpaired means they are not present in the same shell. So, first electron, second electron does not get paired. Second electron goes to the next shell. Third electron goes to the next shell. If you take the case of D, 5 electrons will be occupied by 5 orbitals. Only the sixth electron will come to the first orbital. Similarly is the case with the f orbital. 7 electrons will be occupying in 7 different orbitals. Only the 8th electron will come to the first seat. Like that. That is meant by this Hund's rule. Hund's rule of multiplicity. If same energy of both states, electrons fill in the increasing order of energy level. Hund's rule, if the energies are same, electrons tend to remain unpaired. Lastly, Pauli's exclusion principle, which states that no two electrons will have all the quantum numbers same. Pauli excludes the same nature of all the quantum numbers. The essence of Pauli's exclusion principle, no two electrons in an atom will have all the quantum numbers equal. So, if 3 quantum numbers are equal, 4th quantum number will automatically be different. So, if you take the case of 3 quantum numbers, you can have k shell, s orbital, only one type of s orbital. So, L shell, p orbital, px orbital. Px orbital can also 2 electrons, but one electron with clockwise spin, another electron with anti-clockwise spin. If you take the case of 2p electron, principal quantum number, symmetrical quantum number, magnetic quantum number, 2px electron, all these are same. At least spin quantum number changes. That is the essence. Based on these 3 rules, electronic arrangements are written. That you have studied, that is called electronic configuration. So 1s2, 2s2, 1s1, 1s2, 2s1, 2s2. First shell contains only s orbital. Second shell contains s orbital and p orbital. Third shell contains s orbital, p orbital, d orbital. Fourth shell contains, shell means k, l, m, that is to be noted. So, fourth shell contains s orbital, p orbital, d orbital, f orbital. Only one type of s orbital, each can accommodate 2 electrons. So, maximum number of electrons in s orbital is 2. Maximum number of electrons. But in the case of L shell, 1 s orbital and 3 types of p orbital, total number of orbitals is 4. Each orbital can accommodate 2 electrons, 4 into 2, 8 electrons. Second shell can accommodate a maximum of 8 electrons. So, in the M shell, there are 3 types of subshells. S orbital, subshells are called orbitals, s orbital, p orbital and d orbital. Only one type of s orbital, denoted as s. There are 3 types of p orbital, denoted as 3p. There are 5 types of d orbital. So, total number of orbital 1 plus 3, 4, 4 plus 9, 4 plus 5 equal to 9 orbitals are there. In each orbital, you can have 2 electrons. This presence of 2 electrons in each orbital is given by Pauli's. How it is possible that 2 electrons are possible in an orbital, one with the clockwise spin, another with the anti-clockwise spin. One spins in the clockwise direction, another spins in the anti-clockwise direction. This holds good for all the orbitals. S orbital, one with the clockwise and another anti-clockwise, like that. Next shell is the fourth shell, designated as capital N shell. Subshells are 4 types of subshells. S orbital, subshells are all called orbitals, recalling. S orbital, P orbital, D orbital, F orbital. The same arrangement. 1s, 3p and 5d. So F orbital, there are 7 types of F orbitals, 7f. So degeneracy in terms of odd numbers. 1 plus 3, 4, 4 plus 5, 9, 9 plus 7, 16 orbitals are there. Each orbital, one with the clockwise spin, another with the anti-clockwise spin. Electron with the clockwise spin is represented in this fashion. Electron with the anti-clockwise spin is represented in this fashion. So for each orbital, number of electrons, 32 electrons. That is meant. So N shell can accommodate 32 electrons. M shell accommodates 18 electrons. L shell accommodates 8 electrons. K shell can accommodate only 2 electrons. So the shell nearest to the nucleus can accommodate only 2 electrons. Shell farthest from the nucleus accommodates 32 electrons. So how each electron is identified? So that is the essence of Pauli's. One with the clockwise spin, another with the anti-clockwise spin. So these rules, these 3 rules. So if the electron is present in the K shell S orbital, it is called 1s electron. If the electron is present in the L shell, it is represented as 2s and 2p. And 2p can be 2px or 2py and 2pz. Third shell, it is going on increasing like this. 3s, 3p, there are 3 types, and 3d, 5 types 3d. And 4 means 4s, 4p, 4d and 4f. Similarly, 5s, 5p, 5d, 5f, 5g electrons are not possible. They are the highest energy level. 6f, 4f are there, but not 5g. That is to be noted. You will see. These arrangements are denoted by electronic configuration. So there is a chart, you are aware. So it will be represented in this fashion. 2s, 2p, 3s, 3p, 3d, 4s, 4p. So it will follow some, in the books you might have studied about how off-bow principle is governed by different rules. That is to be noted. 1s is first filled, then 2s is filled, then 2p, then 3s, then 3p, 3d will not be filled. Next to 3p, 4s, then only 3d. Because 3d has the higher energy content than 4s. You will see, that is to be noted. Similarly, if you take only after 6s, you will come 4f. So what is the meaning of this letter? 6s is less than 4f. 6s energy level is lower than that of 4f. So even though 4f is inner orbital, it has maximum energy. 6s is outer orbital, it has lower energy. So nothing to do with the distance from the nucleus and the energy of the orbital. We have seen from the Rydberg constant certain these are to be noted in the electronic configuration. They are following these 3 rules, electronic configurations for elements are written, which explains the different behavior that can be assessed in due course. All the properties of elements are based on only the electronic configuration. Electronic configuration can be written also for atoms, also for molecules. Atomic orbital, molecular orbital is present is in atoms, that is called atomic orbital. Orbital present in molecules, it is called molecular orbital. Lastly, we have seen a word called node. So there is a word written as node. Node is the sites of minimum electron density. Sites of minimum electron. What is meant by sites? S-I-T-E-S. Sites, places of minimum electron density. You write. So this is here electron density is there plus here also electron density. Left side also electron density is there. In the in the intersecting point, electrons will never come. During its motion, when it comes to this particle, next position is here. Intersecting portion, this is called node. It is minimum electron density regions. Nodes are minimum electron density regions. This is of two types: radial nodes, normal nodes. Radial nodes and normal nodes are given by in terms of quantum numbers, which we will see in sums to work out later. So at present you have to have a clear understanding of the electronic configuration in terms of shells, subshells oriented in different directions according to the magnetic field, that is called magnetic quantum number. Lastly, in the position, they are stable in the spinning position, whether it is spinning in the clockwise or anti-clockwise direction. These are to be noted. So this electronic configuration gives information about the further variation of properties of elements as well as compounds.